Okay, what we're going to be doing today is solving linear equations by addition. But first, what I need to introduce you to is actually inverse operations. What are inverse operations? Okay? Inverse operations. Basically, what inverse operations do, they undo the current operation. Okay, they're undoing the current operation here. Let me rewrite this. They're undoing the current operation. Now, let's go ahead and make a table here. Let's make a little chart here so that we can understand this a lot better here. Now, let's say on this chart I'm dealing with let's see how I can draw this here. Well, let me do it like this. Let's draw it straight down the middle. Okay, let's say this is for addition, this is for subtraction, this is for multiplication, and that's for division. Okay, so this, let's call this the operation. And then let's call this the inverse down here. Okay, the inverse, what is going to undo this operation here? Well, just so you guys will be a little bit more comfortable, let me go ahead and put inverse in a different color. Let's put it in this color here, the inverse. Okay, well, what is this inverse thing here that we've been talking about? Well, let's take a look here. If we have, let's say, the operation addition, which is a plus sign, correct? If we have addition, the only thing that would undo addition is what we call subtraction. It's the inverse of that. It's subtraction, right? Now, let's say if we have, and you'll see all these in these examples that we're doing here when we're solving linear equations. Let's say we have subtraction. What is the inverse of subtraction? Well, the inverse of subtraction must be addition, right? It must be addition. Now, let's say we have multiplication. We have multiplication here. What could the inverse of multiplication be? Well, it's obviously going to be division, because if something's multiplied, we'll divide by it in order to get, in order to isolate that variable. And you'll see that, like I said, in these linear equations that we'll be solving soon. Let's say we have division. What is the inverse of division? Well, obviously it's multiplication. Where's my color here? Obviously it's multiplication. Okay? So what this says here is that addition, the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. So anytime we're solving equations and we see we have something added and we want to get rid of it, it's added, it's keeping my variable from being alone, we want to get rid of it, we're going to have to do its inverse operation. We're going to have to subtract that from both sides. Same difference here. If we're subtracting something, like let's say we have r minus 16 is equal to negative 7. Minus 16 is being subtracted, so we're going to have to actually do its inverse operation to get rid of it. The reason that we do inverse operation is so it will cancel out. And we'll be left with 0 on that side. And we're one step closer to having our variable isolated. Now, enough talk about it. Let's go ahead and get into some problems. But we're going to keep this table up here because we need to review back to it for further when we're doing these examples here. Okay? First example here. Let's say it says, let's do example number 1. Okay, and it says, let's solve. It says solve here. It says solve. Let's say we have r plus 16 is equal to a minus 7. Okay? Well, r plus 16 is equal to a minus 7. We basically, in this equation, what we want to do is we want to get this r on a side by itself. We want r to be alone. We want the final answer should look like this. R is equal to something. Okay? Now, in order for this to happen, we must get rid of what's keeping r from being on a side by itself, which is what? Well, this 16 here is keeping r from being on a side by itself. Well, let's get rid of it. 16 is added, so in order to get rid of it, we must do its inverse operation so it cancels. So what's the inverse operation of addition? Well, it's subtraction. So let's go ahead and do that. Let's subtract 16 from both sides. Now, this is the thing in equations. What you do to one side, you must do to the other side. So if we of the equal sign. So if we subtract 16 from this side of the equal sign, we must subtract 16 from the other side of the equal sign. Now, the reason this is because we want to keep everything balanced. Let me put this in a box here. We want to keep everything balanced. So it should be balanced. Balance. Your equations should be balanced. Okay, so if I have A should be equal to A, B should be equal to B. If I have C minus A, that should be equal to C minus A. Our equations, you have to think of it like a scale, like a balance beam. You need the equal weight on each side. You know, on the playground when you have the I can't think of the name of the playground toy, but it's, you know, the thing where you have one person sitting on one side, the seesaw. There we go. You have one person on one side and the other person on another. You want equal weights because you want that to be balanced. That's how you have to look at it. Okay? So, what you do to one side, do to the other. So, what you do to one side, do to the other. Okay? What we do to one side, we'll do to the other side. And this is so that everything stays balanced. Okay? Let's say just so you can, another small proof of this here. Let's say we have table of apples here. Let's say we have a table of apples. We have one apple, we have another apple, and another apple. Let's say we have 5 apples here. And then we have 5 apples over here. Let's say we have 5 apples over here. 1, 2, 3, 4, 5. Let's say we have these 5 apples, right? Well, we want everything to stay equal because there's an equal sign in between here. There's an equal sign in between here. And it says that everything must stay equal to each other, right? So let's go ahead and see what we'll do here. Let's say Sam, he eats an apple here. He eats an apple. Well, now we have 4 apples are equal to 5 apples, but that's not true, right? So if Sam eats an apple if he eats a red apple, he also must eat a green apple. So we're staying equal. Okay, so if Sam takes 2 apples away from red, in order for this to be an equal, in order for this to stay balanced, this equation to stay balanced, Sam must eat 2 apples from green. Okay, we have to do the same thing on both sides. We can't be biased and only do it on one side. Just because he only likes red doesn't mean he can only eat red. He has to eat green as well, or at least take it away from the total quantity. Okay, now let's go ahead and get back up to our example problem here that we have. Now that we've done the inverse operation on both sides by subtracting 16, we can go ahead and do our basic integer rules. A positive 16 minus a 16. So we have a positive 16, and basically we're subtracting 16 should be equal to what? Well, that should be equal to 0. And this here is the whole point of why we do inverse operations. So it will cancel out. Okay? Then we bring down this r. We have r plus 0, or the same thing as not writing anything for r. Right? I mean, not writing anything with r, because r plus 0 is still going to give me r. So we'll just go ahead and say it's r is equal to. Well, we're one step closer to what I want down here. This is what I want, remember? So we're one step closer to that, to this idea here. Right? So now let's just do these integer rules over here. A negative 7 minus 16. Well, negative 7 minus 16, that'd be a minus 23. A minus 23. And that is your answer. This is your answer. R is equal to a minus 23. That's the whole point of equations. We want to solve for a certain variable. Right? We want these variables to be equal to, we want the variable equal to a quantity. Okay, so we can also check this. Let's go ahead and check this to make sure it's right. Well, if in this case it says that r plus 16 is equal to negative 7, and r is equal to negative 23, let's go ahead and substitute. So it says r plus 16 is equal to a negative 7. And let's say it says r is equal to a minus 23, because that's what we have here, correct? So let's see if our algebra is actually true. Well, let's take this minus 23 and substitute it in for this r here, and we'll have a minus 23 plus 16 is equal to a minus 7. Well, is that true? If you know your integer rules, minus 23 plus 16, you're actually going to end up subtracting, and you will take the sign of the number with the largest absolute value, and you'll actually end up getting a negative 7 is equal to a negative 7. And it is true. If it checks out on both sides, then it of course is true. So these two are equal. Therefore, this value of r is indeed true. Okay? Well, go ahead and take a minute, pause the video, write this example here down, and let's move on to another example. Okay? Let's see here. Let's go ahead. Let's take an example. Well, let's do this here. Let's do this example here. Example number 2. Okay, let's go ahead and take this. It says the same rule. It says for us to, ooh, that's too dark for you guys to see. It says the same rule for us to solve. Okay, let's say I have 11, well, let's say minus 110 plus 4, now, let's say plus p. Minus 110 plus p is equal to 116. Okay? Well, this is a very simple equation. Just has larger numbers. Okay? A very simple equation. Well, let me break this down to you in English here for a second. What this says is negative 110 negative, let me write this down for you. So this says negative 110 plus what number will give me 116? And when we translate this into algebra, this is how it looks here, right? Okay, so what do we do here? Well, you may ask yourself and say that this 110 is added, but if you actually look at it, we're going to take the sign of 110. So just like when we're in here, when we had r plus 16 is equal to a minus 7, we took the sign of it, which was a positive. So that means we did the inverse operation, which would be a negative. So we didn't end up subtracting, right? Same thing here. Let's get 110 away from this side with p, because we want p to be equal to something. Okay, so let's see. 110 has a negative sign, so we have to do the inverse operation of that. Well, a negative, the inverse operation will be a what? A positive. So we're going to end up adding. So let's add 110 to both sides. Well, if we remember exactly why we did this inverse operation is so that these two will cancel. A negative 110 plus 110, those will give me 0. So we say they cancel out. Because what are they? They're inverses of each other. So then I have just a positive p. I have 0, and like I said, we don't have to write 0 here. So it'll be 100. So it'll be actually 0 plus p, which will be p, is equal to 116 plus 110. So 116 plus 110 will give me 226. Okay? 226 is my answer. So it says P is equal to 226. Well, let's go ahead and do a check here, just so we can make sure this is right. Let's do a check. Okay, so what this equation here says, it says that negative 110 plus P is equal to 116. Or in English, it says negative 110 plus what will give me 116. Well, based on our great equation solving skills, we said that negative 110 plus p, and p is equal to 226, so negative 110 plus 226 should be equal to 116. That's exactly what we said. Well, let's see. We're actually going to end up subtracting here since they have different signs. So negative 110 plus 226, we get 116 because we take the sign of the number with the largest absolute value, which will be 116. 116 over here, and I have 116 here. So they both check out on both sides. I have the same thing on both sides. So that means this equation is true. So P does indeed equal 226, okay? That is true. Now, in the next video, we'll actually talk about subtraction. And then in the further videos, we'll talk about solving equations by addition. I'm sorry, not addition, but division and multiplication. Now, this video here was not just for addition. We actually did do a subtraction problem here. So we'll go ahead and put by addition/subtraction. Okay, now let's go ahead and get one more problem dealing with some addition. Let's do one more addition and one more subtraction in this video here. Okay. Give me 1 second here. Let me think of a problem here. Okay, let's do this word problem here. Let's go ahead and do this word problem. It says a traffic helicopter. Well, let me write it down for you guys. Okay, what this says here is a traffic helicopter descended 160 meters to observe road conditions. Okay, it leveled off at 225 meters. Let me write that in here. It needs to be a capital. It leveled off at 225 meters. What was its original altitude? Altitude is the same thing as its original height. Okay, so this is actually an application problem. Now we're going to actually convert this English into words so that we can understand this here. Okay, well, it says a traffic helicopter descended, so that means it went down. So it went down 160 meters, okay, to observe road conditions. And it said it leveled off at 225 meters. So we want to know what was its original height. Okay, well, if the traffic helicopter descended 160 meters, that means its original height, we're going to have its original, right, its original altitude minus 160, because we went down 160 meters. So its original altitude minus 160 meters, and then it says it leveled off at 225. So that means if it went down 160 meters, it descended 160 meters to get to the height of 225. So this means that the original altitude minus 160 meters will give me 225. Well, let's go ahead and solve this, because this is an equation. Now, I don't want to confuse you or anything with all these different words and letters, so let's go ahead and let some stuff stand for some things. So the altitude, the original altitude, is what we want to find. We'll say the original altitude will equal A. Okay, will equal A. So let's go ahead and do that. Let's go ahead and solve this here problem. We'll say that A, the original altitude, minus 160 is equal to 225, right? So because what this says is that we started off at a height. Okay, so let's see if I can draw this out here so you can understand a lot better. We started off at our original altitude, which is A. We went down 160 meters, okay? We went down 160 meters. So when we're up here at the original altitude, we're up here where the height of all the buildings are. Let's see if I can draw this. We're up here where the height of all the buildings are and everything. Then we descended 160 meters. And because we want to get to the road here. We want to get to this road. We want to get to this road. So this is the original altitude. We drop down 160 meters and we're leveling off about right here. We're leveling off about right here at 225 meters. Okay? So we started here and we ended up here. So this will be the altitude, the original altitude minus 160 meters should be equal to 225. But what was this original altitude? Let's find it. Well, if A minus 160 is equal to 225, well, we want to get A by itself. So what is 160? What's the sign of 160? Is it positive or is it negative? It's negative, so it means it's subtracted. So we're going to do the inverse operation of subtraction, which is addition, right? Subtraction, so that means the inverse would be addition. So let's go ahead and add 160 to both sides. Okay, because what we do to one side, we must also do to the other. These here will cancel because a negative 160 plus 160 will be equal to 0, which is the same thing as them canceling out. Okay, we bring this a down, we're left with a is equal to 225 plus 160. Well, what's that? 225 plus 160 should give you 385. So this says A is equal to 385. That's what that means, that the original altitude, so what does A stand for? A stands for the original altitude. So that means that our original altitude was what? 385 meters. Okay, meters. Let's go ahead and give this a check here. Let's go ahead and check it, just so we can know that it's right. Oh, let's check it, just so we can know that it's right. Okay, so it says that the original altitude minus 160 meters should be 225. Well, the original altitude, which is A, so we'll say 385 minus 100, and then he flew down 160 meters. So we started from here, which we'll say is 385, and then he flew down here to 160 meters. So we subtracted 160 meters. That should be equal to 225 meters based on our problem. Well, all we do is 385 minus 160, and we end up getting 225 is equal to 225. And this checks out on both sides. Therefore, this equation is true for the original altitude. So that means our original altitude was 385 feet. Meters. So this is the same thing. If you see a helicopter flying and they ask you to calculate to find its original altitude, this is how we do it. We take it through this process here. Okay, so this is our video lesson on solving equations by using addition only and addition and subtraction only. Our next video we'll take a look at some division here. I said I'd do one more subtraction problem, so let me do one more here. Let's do a simple one. Let's say, I'm going to leave this actually for you guys. You can pause the video and do it yourself, and you can resume it, and I'll have the answer here for you. Let's say we have 16 plus 49 is equal to that's not even 16 plus x is equal to 49. Well, let's go ahead and do this here. So 16 plus x is equal to 49. Well, 16, we want x to be on a side by itself because we're solving for the variable. That's what our instructions say. Let's say solve for x. Okay, so we're solving for this x here. So we're dealing with 16. We want to get it on a side by itself. Well, what's the sign of 16? 16 is positive. So if we look back up here, the inverse of addition is subtraction. So since 16 is positive, we're going to end up subtracting 16 from both sides. We subtract it from this side of the equal sign and then from this side. Well, when we subtract it from this side, 16 minus 16 will give me 0. So those cancel. And then I bring this x here down and I'm left with x is equal to 49 minus 16. Which was what? Which is what? 33. X is equal to 33. Let's do a check. Actually, I'm going to go ahead and leave the check to you. Go ahead and check this. Remember the process that we did before to do checks. Go ahead. I'm pretty sure you're very advanced at this now and proficient at this. So go ahead and check this problem to make sure that 16 plus x is equal to 49 for the value of x that we found. Okay?